Welcome. This video is for iteration and calculus for part 2 for A level P3. So in part 1 I have done from question number 1 to 6. Now I'm starting from question number 7. The equation of the given curve is given x plus dy by dx and verify that dy by dx equals to 1 when x is pi by 4. So y equals to square root of tan x. Now we need to memorize one formula. If y equals to square root of x, then what will be dy by dx will become 1 upon 2 square root of x. Easy method to remember. So over here dy by dx should be equals to 1 upon 2 square root of tan x. But we have to use the chain rule. Tan x derivative. What is tan x derivative? Secant square x. This is going to be the dy by dx. Now what am I going to do? I am going to plug in x equals to pi upon 4. So dy by dx at x equals pi by 4. So what does that becomes? 1 upon 2 square root of tan pi by 4 times secant square pi upon 4. Tan pi upon 4 is 1, 2 square root of 1. Secant pi upon 4 is root 2 whole square. Simplify that, I'll be getting it out 1. Then the value of dy by dx is also 1 at another point where x equals to a. Show that this one. So what was dy by dx? Dy by dx was secant square x divided by 2 square root of tan x equals to 1. So secant square x is 1 plus tan square x divided by 2 square root of tan x equals to 1. So tan x, what is that? We'll be writing it as a. So what does that becomes? 1 plus tan square a divided by 2 square root of tan a equals to 1. Then what am I going to do? Tan a equals to t. So it becomes 1 plus t square divided by 2 square root of t equals to 1. 1 plus 1 plus t square equals to 2 square root t. Then 1 plus t square whole square equals to 2 root t whole square. Then it becomes 1 plus t power 4 plus 2t square equals to 4t. So it becomes t power 4 plus 2t square minus 4t plus 1 equals to 0. Now we know that when a equals to pi by 4, t equals to tan pi by 4, which is going to be 1. So t minus 1 is a factor. T minus 1 is a factor. So what am I going to do? I am going to do the long division for this. So this one was here. So I move all these. Then I will be getting t minus 1 as a factor. Now what am I going to do? I am going to do the long division. T power 4 plus 0 to cube plus 2t square minus 4t plus 1 divided with t minus 1. So I multiply with t cube. So it becomes t power 4 minus t cube. So it becomes t cube and bring it down plus 2t square. Next I multiply with t square. So it becomes t cube minus t square. So this becomes 3t square. Bring it down. So it becomes negative 4t. Then I multiply with plus 3t. So 3t square minus 3t. So it becomes negative t. Then bring it down plus 1. Then multiply with negative 1. So it becomes negative t plus 1. So remainder is 0. So it becomes t minus 1 times t cube plus t square plus 3t minus 1 equals to 0. So t cube plus t square plus 3t minus 1 equals to 0. Use the iterative formula. So we know that from the graph The a value is lying between 0 to pi by 4. So I can take any value as the initial value. I am going to take initial value as 0, 0.0000. So a2 becomes 0.3218, a3 becomes 0.2767, a4 becomes 0.2904, a5 becomes 0.2866, a6 becomes 0.2877. So a4, a5 and a6 all round to 0.29 to 2 dp. So a equals to 0.29. Question number 8. The y equals to x square root x as a stationary point. Show that tan a equals to negative half a. So y equals to x square root of sin x. So I will be doing divided by dx. X as it is, square root of sin x formula is 2 square root of sin x. Sin x derivative is nothing but what? Cos x. Plus then square root of sin x as it is, and x derivative is going to be nothing but how much? 1. So what am I going to get that one now? This should be equals to 0. So x cos x upon 2 square root of sin x plus square root of sin x should be equals to 0. Then what am I going to do? I am going to multiply entire equation with square root of sin x. So what does that becomes? X cos x upon 2 plus sin x equals to 0. So sin x equals to minus 1 upon 2 x cos x. Then sin x upon cos x equals to negative 1 upon 2 x. Tan x equals to negative 1 upon 2 x. So what do I get it out? Tan a equals to negative 1 upon 2 a. Next, verify by calculation, it lies between 0 this much. So my f of x will become tan x plus half x. Then f of 2 will become tan 2 plus half of 2, which is minus 1.185. Then I'll find f of 2.5. Tan 2.5 plus half of 2.5, which is going to be 0.503. So again, sign change and write the entire sentence. Show that the sequence is in the interval given by the formula converges, then it converges to the root of this equation A. So x equals to pi minus tan inverse half x. So tan inverse half x equals to pi minus x. So half x equals to tan pi minus x. Now tan pi minus x formula we know. What is that one? Half x equals to tan a minus tan b by 1 plus tan a tan b. So half x equals to 0 minus tan x by 1 plus 0. So half x equals to negative tan x. So tan x equals to negative half x. Now start with the initial value as 2.0000. So you'll be getting it at 2.3562. The next 3 becomes 2.2746. The next 4 becomes 2.2920. X5 becomes 2.2883. X6 becomes 2.2891. So X4, X5 and X6 all round to 2.29 to 2 dp. So x equals to 2.29. Question number 9. The constant a is such that this must show that a equals to. So it is integration by factor. What is this? By parts. Highlight, algebra and exponential. So first function, integral of second function minus integral of derivative of first, integral of second. So it becomes minus x power e power minus 2x by 2 plus 1 upon 2 integral of e power minus 2x dx minus x e power minus 2x upon 2 plus 1 upon 2 e power minus 2x upon minus 2. Then the limits. What are the limits? 0 to a. Plug in a. So minus a upon 2 e power minus 2a minus 1 upon 4 e power minus 2a minus 0 minus 1 upon 4 e power 0. So what do I get? Minus a upon 2 e power minus 2a minus 1 upon 4 e power minus 2a plus 1 upon 4. This should be equals to 1 upon 8. So multiply totally by 8. It becomes negative 4a e power minus 2a minus 2 e power minus 2a plus 2 equals to 1. So minus 4a e power minus 2a minus 2 e power minus 2a plus 1 equals to 0. E power negative 2a common minus 4a minus 4a common means also plus 2 equals to minus 1. So e power minus 2a equals to 1 upon 4a plus 2. Apply ln on both sides. So negative 2a equals to ln of 4a plus 2 to the power of minus 1. So negative 2a equals to negative ln of 4a plus 2. Negative negative cancels. So a equals to 1 upon 2 ln of 4a plus 2. Verify by calculation, it lies between. So first of all, f of a is a minus 1 upon 2 ln of 4a plus 2. So I'll be finding f of 0.5. So 0.5 minus 1 upon 2 ln of 2 plus 2, which is minus 0.193. Then f of 1. 1 minus 1 upon 2 ln of 4 plus 2, which is 0.104. So you have to write sign change and the entire answer. Use the iterative formula. So an plus 1 equals to 1 upon 2 ln of 4an plus 2. So a1 equals to 0.5000, a2 equals to 0.6931, a3 equals to 0.7814, a4 equals to 0.8171, a5 equals to 0.8309, a6 equals to 0.8361, a7 equals to 0.8380, and a8 equals to 0.8388. You can see that all these are remembering to or rounding off to 0.84. 0.84. So what I can write, a6, a7 and a8 all round to 0.84 to 2 decimal place. So a equals to 0.84. Coming to question number 10. Again, integration by parts. I have logarithmic and algebraic. So first function, integral of second function is x cubed by 3 minus integral of derivative of first function 1 upon x. Carry forward this x cubed by 3 dx. X cubed ln x upon 3 minus 1 upon 3 integral of x square dx. X cubed ln x upon 3 minus 1 upon 3 x cubed by 3. The limits 1 to a, 1 to a, 1 to a, 1 to a, and 1 to a. So it becomes, substitute upper limit 1 upon 3 a cube ln a minus 1 upon 9 a cube minus 1 upon 3 times 1 cube times ln 1 minus 1 upon 9 times 1 cube. So 1 upon 3 a cube ln a minus 1 upon 9 a cube plus 1 upon 9 equals to 4. So 3a cube ln a minus a cube plus 1 equals to 36. How could I able to get that one? Multiply by 9. So 3a cube ln a minus a cube equals to 35. A cube common, 3 ln a minus 1 equals to 35. A cube equals to 35 upon 3 ln A minus 1. A equals to cube root of 35 upon 3 ln A minus 1 minus 1. Now verify by calculation. So first of all I have to find f of A, which is A minus 35 upon 3 ln A minus 1 cube root. So I'm going to get f of 2.4, which is going to be 2.4 minus cube root of 35 divided by 3 ln 2.4 minus 1 minus 0.382. Then f of 2.8 minus cube root of 35 divided by 3 ln 2.8 minus 1 0.241. So you should be writing it out, sign change. Use the iterative formula. A power n plus 1 equals to cube root of 35 divided by 3 ln an minus 1. So a1 equals to 2.4000, a2 equals to 2.7815, a3 equals to 2.5671, a4 equals to 2.6751, a5 equals to 2.6774, a6 will be equal to 2.6473, a7 will be equals to 2.6315, a8 becomes 2.6398, a9 will be equals to 2.6354. So we can see that a8, a9, a10 all round to 2.64. So x equals to 2.64. This is 2.64. This is also 2.64. And I found it out a10 also, which is 2.6377, which is also equals to 2.64. Question number 11. So this is a tangent. The gradient is 12. So I have to find dy by dx. So dy by dx equals to cos square x whole square, then divided by cos square x times 1 plus minus x times 2 cos x, and cos x derivative is negative sin x. So x equals to a, dy by dx equals to 12. So 12 equals to cos square a plus 2a sin a cos a divided by cos square cos to the power of 4a equals to 12. So what does that becomes? Cos square a plus 2a sin a cos a equals to 12 cos to the power of 4a. So one cos gets cancels. Then what I will be left over with? Cos a plus 2a sin a equals to 12 cos cube a. So cos a plus 2a sin a by 12 equals to cos cube a. So what does cos a becomes now? Cube root of cos a plus 2a sin a divided by 12. So a equals to cos inverse of cube root of cos a plus 2a sin a divided by 12. Verify by calculation. So first of all find f of a, which is a minus cos inverse of cube root of cos a plus 2a sin a divided by 12. So I find f of 0.9, which is 0.9 minus cos inverse of cube root of cos of 0.9 plus 2 times of 0.9 sine of 0.9 divided by 12 minus 0.0846. Then I find f of 1 minus cos inverse of cube root of cos 1 plus 2 times 1 times sine 1 divided by 12, which is 0.0358. So again, you get sign change and write all the things. Now use the iterative formula. An plus 1 equals to cos inverse of cube root of cos an plus 2an sin an divided by 12. So a1 equals to 0.900, a2 equals to 0.9846, a3 equals to 0.9673, a4 equals to 0.9708, a5 equals to 0.9701, 0.97, 0.97 and 0.97. So therefore a3, a4 and a5 all round to 0.97 to 2 decimal place. So a equals to 0.97. And the last question, question number 12. Then these two are meeting over here. So what can I do? Cos x equals to k upon 1 plus x. So I'll be finding dy by dx. Dy by dx is nothing but what? Minus sin x. And dy by dx for this guy will be minus k times 1 plus x whole to the power of minus 2. Both should be equal. So minus minus cancels. Sin x equals to k upon 1 plus x whole square. So then what do I do? Sin x divided by cos x. Sin x was k upon 1 plus x whole square. Cos x is k upon 1 plus x. So what do I get from there? Tan x. Tan x equals to 1 upon 1 plus x, because k gets cancels and 1 plus x and 1 plus x gets cancels. Tan x equal to 1 upon 1 plus x. So tan p equals to 1 upon 1 plus p. So what I have done it out, k upon 1 plus x whole square. This is a fraction, it becomes 1 plus x upon k. Then we can see that k and k gets cancels. 1 plus x and 1 plus x gets cancels, and you are left over with 1 upon 1 plus x. Iteration p1 equals to 0.000005 5 decimals, p2 0.78540, p3 0.510456, p4 0.58477, p5 0.56291, p6 0.56919, p7 0.56737, p8 0.56790, p9 0.56775, p10 0.56779. So p8, p9 and p10 all round to 0.568 to 3 decimal place. So x is equal to 0.568. So this is 0.568, this is 0.568, and this is also 0.568. So we got cos x equals to k upon 1 plus x. So cos 0.568 equals to k upon 1 plus 0.568. So k equals to 1.568 cos times of 0.568, which is going to be 1.32. So that completes this video. See you in the next video. Bye.